Pleased to introduce our first speaker this morning. Our guest is Dr. Eric Darr, and he's the chief of the Division of HIV Medicine at Harbor-UCLA Medical Center, and an investigator at the Lundqvist Institute at Harbor, which used to be at the LA Biomed, and professor of medicine at David Geffen School of Medicine at UCLA. He's an infectious disease trained clinician investigator with more than 25 years of experience providing HIV care and conducting research related to HIV/AIDS. Since the beginning of the COVID-19 pandemic, he's been focusing the majority of his attention toward research related to treatment and prevention of this disease. As part of this effort, he's been working with the federal government's response to the pandemic called Operation Warp Speed. This includes being one of the lead investigators on research related to the treatment of people with mild COVID-19 disease who have not yet been admitted to the hospital. He's also part of the Coronavirus Prevention Network and will be one of the local leads for a soon-to-start vaccine study, which will be conducted at the Lundqvist Institute at Harbor-UCLA Medical Center here in the South Bay. And we're all very excited to have you with us today, and also excited about the possibility of having this study right here in the South Bay. So thank you for joining us.
Well, Britt, thank you so much for this opportunity, and thank all of you on the call for joining and allowing me to talk a little bit about prevention. I'm going to go ahead and share my slides. Let's see. Hopefully you can all see it, my slides.
Yes, thank you.
Great, great. So what I'm going to do is briefly sort of give you an overview of what's going on with COVID, why it's important that I talk to groups like this in advance of vaccine trials, and then tell you a little bit about what's going to be going on with vaccine studies really across the country, but in particular here in the South Bay and other parts of LA County. As Britt mentioned, I wear a lot of hats. I'm an investigator at the Lundqvist Institute, which is the nonprofit research institute that supports the research activities of faculty at Harbor-UCLA. Infectious disease trained, but have focused my entire career until, I would say, January of this year on HIV disease, and have watched the evolution of HIV from universally deadly disease to, for many people, a chronic, completely manageable disease. I work at Harbor-UCLA Medical Center clinically, and I'm a professor at the Geffen School at UCLA. And I'm using this slide that shows the COVID-19 Prevention Network, because what I'm going to be talking about is mostly being done through that network. For those of you who know Harbor-UCLA, we're one of the safety net hospitals that serve sort of the Long Beach area. Pretty large catchment area for the underserved, primarily a population of Latinx and Black patients. And this is the entrance of our medical center on the left. And then we have this nonprofit research institute called the Lundqvist Institute, formerly LA Biomed. For those who've been around for a while, it was prior to that REI. But it really is a completely independent research institute that sits on the campus at Harbor-UCLA. And there are several research buildings in this vicinity. The one on the lower right is the one that my research group is in. It's called the Chronic Disease and Clinical Research Center, or the CDCRC. So I see my patients in the facilities on the left and in our clinics, and I do our research, and my research staff is housed in the building on the right. Many of you have been tracking the COVID-19 pandemic since it was originally described literally on December 31st of 2019, and its evolution over the last 6 months. This is the Johns Hopkins site. If you haven't looked at it, just all you have to do is do Johns Hopkins and COVID-19. It's updated practically minute to minute and shows what's going on globally and nationally and across different states and regions. This is from all of about 8 days ago, where it lists in the United States what now exceeds 4 million cases and 150,000 deaths. And as you know, the United States is the leader, unfortunately, in cases and deaths across the globe. This is showing what's going on by region. The dark black color represents the highest number of cases on the left, and the darker red color, the most deaths on the right. And while the United States is a leader, so is California, where we all live. So this is a problem that has not gone away, did not go away with a few months of time, did not go away with weather, and unfortunately did not completely go away even with the lockdown, although that certainly had an impact on cases. This is a slide that deals with one of the issues that's extremely important to our discussion, and that we know that this novel coronavirus that causes this disease, COVID-19, affects everybody. And we could debate about whether people who are younger are less likely to get infected or not. There may or may not be subtle differences. But we do know that across the population, since the early reports from China and continues here in the US, that if you get infected, we now know that probably about 40% of people have no symptoms at all. And another 40% or 45% will have very mild symptoms. Whether it'll be like a common cold or a bad case of the flu, it will not be severe or life-threatening. About 15 to 20% of the people who get infected will develop severe disease requiring hospitalization. About 5%, 1 in 20, will end up in an intensive care unit. And probably about 1%, or maybe a little less than that, but 1 in 100, 1 in 200 of people who are infected with this virus will die. This is on the order of 5 or 10 times higher than an average flu season. And the rate of spread is obviously extremely high and has not gone away despite the change in the weather. So who's at the greatest risk for getting sick? And this is one example of data from the US that was previously shown in the early part of the epidemic in China, showing the group of people who are at the highest risk of getting infected. And it shows, and they're also, it turns out to be at the highest risk of severe disease and hospitalization. And that's the greater than or equal to 65 years. So we hear that a lot, right? People greater than 60 or greater than 65. But as you can see in the red line, even those who are greater than 50, and even those in the 20 to 49-year-old age group are at somewhat higher risk than children. But really, you see a pretty dramatic increase by the time people are in their 50s, and much, much greater in people who are over 65. And remember, it's from this group that are hospitalized that we have that population who end up being put on ventilators and sometimes who die from the disease. So if you were going to target a population for an intervention to impact the severity of this disease, you'd want to do it in the people who are at the greatest risk for a bad outcome. If everybody infected just had a mild cold-like illness, we wouldn't be having this conversation, and we certainly wouldn't be locking down the global economy. We would just let it ride, and that would be the end of it. But we have a substantial mortality, and targeting particularly people who are older. We also know that people who have comorbid conditions like diabetes, hypertension, heart disease, lung disease, who are otherwise immunosuppressed, are also at higher risk for hospitalization and death. So that's one important population that if we can intervene, either with a treatment or a preventive modality, such as a vaccine, would be our highest priority. The other group, it turns out, is illustrated on the next couple slides. And it turns out that this disease has adversely affected disproportionately people of color. So this is the Asian Pacific Islander, Black, Latinx population. And this looks at the cases by race ethnicity. These are reported cases, not hospitalization or deaths. And you can see that amongst the Black and the Hispanic or Latino, it accounts for over 50% of the cases in the United States, at least in the region reported here by the CDC, compared to the whites, which is about 35%. And we know that these populations of Black, Hispanic, account for about 25% of the US population, but despite that, the cases. Here's data looking at the hospitalizations by race and ethnicity. So here, what they do is they adjust for a sort of per 100,000 population. So it adjusts for the fact that the number of people in these groups is lower in the United States than other groups. And you can see American Indian, Alaskan Natives, non-Hispanic Blacks, and Hispanic or Latino have by far and away the highest rates of hospitalizations. So this is what we've learned over the last 6 months. It's crystal clear that if you're going to worry about the highest risk groups for infection and particularly for bad outcomes, it's going to be people who are older, people who have multiple comorbid conditions that I had mentioned. The other one I forgot to mention is obesity has turned out to be a major player. It's obviously a big issue here in the United States. And then people of color in the United States. So there are lots of reasons that probably account for the predisposition for bad outcomes among ethnic minorities. Part of it is the living and working conditions. They're often in essential industries that have to continue to work, like working in grocery stores, meat packing plants where there have been some real bad outbreaks, residential segregation. People are living in more high density housing environments, obviously sometimes multi-generational. So you have people going out and working, then bringing the infection back home. And while the young people out working may not be at the high risk group, they're bringing it home to those who are at high risk. And then the underlying conditions, these minority groups are at higher risk for a lot of the comorbid conditions that we talk about, ranging from diabetes, hypertension, heart disease, to obesity. Briefly, how is this transmitted? Again, this has gotten a lot of attention. I think you're probably all aware of it. It is transmitted by droplets. These are large droplets that rapidly drop to the ground, and that's why people talk about this 6-foot distance, because even if someone's allowing these droplets to come out when they talk, they'll generally drift to the ground below the level in which somebody who's likely to be exposed by inhaling them or getting them into their eyes. A lot of discussion about how much of this is going on by aerosolization with these smaller droplets that might fill a room if there's poor ventilation. Again, probably less common, especially in people who are not coughing and sneezing. So the distance is one of the important things, the social distancing we've talked about. The other thing is the wearing the mask. The data just seems to get better and better that if people are wearing a mask, they're infectious, whether they're asymptomatic or symptomatic, these droplets get stuck behind the mask. And yes, a little bit might come out the sides, a little bit might come out the front, but it'll be just inches as opposed to feet. In addition, wearing the mask, while it doesn't cover your eyes, so it's not 100% protective, there's increasing data that suggests it probably provides some protection for those who are exposed. So we focus it mostly on a strategy to reduce an infected person from transmitting to other people, especially if they can't maintain that 6-foot distance. But it also probably provides a little protection for those who are uninfected. And the reason the emphasis on the masks for everybody is coming out, especially in the midst of these outbreaks, is because 1, you can't always maintain social distancing, and 2, you really don't know if you're infected for sure. Because, as I said, 40% of people, it's estimated, are infected and have no symptoms. You see at the bottom the fomites, or the environmental stability. We talked a lot at the beginning of the epidemic that these droplets could land on something like a surface that you're working at, or somebody who has contaminated hands might touch those surfaces. Definitely a potential route of transmission, arguing for frequent hand washing and wiping down the surfaces, but the data suggests probably a much, much less common way in which transmission is occurring than by this droplets issue. As far as testing, everybody has seen the people getting their nose swabbed, their throat swabbed, collecting saliva. All of the diagnostics for somebody where you're worried about infection, whether they're symptomatic or asymptomatic right now, rely on actually looking for the virus. And we can find it in any one of these various secretions. Again, throat, saliva, nasal swabs. There are antibody tests, so-called serologic tests out there as well. It's not as clear as to how reliable they are, and generally not useful for somebody who you're worried about actually having infection now. More a tool for potentially looking to see how many people in a community have been previously exposed and developed antibodies. So most you'll hear about testing, and the most important focus should be on this so-called nucleic acid test, looking for the virus itself. So when somebody does get exposed, again, the symptoms range from no symptoms at all to congestion, runny nose, cold-like symptoms. A very relatively common and unusual side effect or symptom has been this loss of taste or smell, very commonly described by cough, sore throat, shortness of breath, diarrhea, lots of different manifestations of this illness. And generally, it's felt that after an exposure, if somebody's going to get infected, it'll occur between 2 and 14 days. Most of the time, if they're going to develop symptoms, it'll be within that first 5 to 6 days, but occasionally as long as 14 days. Really pretty rare after 10 days. So you'll hear a lot about if you've been exposed and you want to prevent yourself from transmitting to other people in case you got sick from exposure, they'll talk about quarantining at home for 14 days so that you're not exposed to other people during that period of time when you may still develop symptoms. And this is just one of two websites that has emerged during this pandemic. This is the so-called treatment guidelines. I've actually had the privilege to be able to be on this treatment guideline panel. Within this website, and if you look at NIH COVID-19 guidelines, you'll find it if you Google that. It talks a lot about general information that we described. It has a lot of links to the CDC, which is another excellent website to get the kind of information that we've talked about. And it talks a lot about where we are with treatment, with most of the treatment really that has evolved being for people sick in the hospital, with some progress in that area, although we still have a way to go. So from a prevention perspective, which was going to be the focus of my discussion, obviously I talked a lot about ways we protect ourselves on a day-to-day basis. And I personally think it is extremely important to protect ourselves is by wearing masks, both for other people as well as perhaps for ourselves, maintaining the social distancing as much as possible. So those are all important means in which you can prevent ourselves. But the other big thing to do is to develop a vaccine. Every major viral infection in the history of the world for which we've had really a good level of success has been through the development of vaccines, going back to smallpox, which has been eradicated, and polio, which is largely eradicated in developed countries, and other vaccines as well. So a vaccine strategy was a high priority moving forward. And vaccine development starts by just identifying the virus. That happened incredibly quickly, literally within a week or so in China. And then coming up with tools in which you can create a vaccine, testing it in animals to see whether it stimulates any kind of an immune response, then doing the human trials, which there's sort of a long process, do human trials to identify the best dose, the safety, and then to ultimately determine if it works, and then eventually approve, and then all importantly, mass production. Because just having a vaccine that's been shown to work is just the beginning. For a virus like this, we're talking about 3 million doses, or 3 million people to vaccinate in the US alone. And this is a global pandemic. So we'll need literally billions of doses, even after we identify an effective vaccine. So this I lifted out of the New York Times. It was an animated graphic, which I couldn't do for this presentation. But I apologize that it's not a little light, but what it basically talks about is the usual path of development. The average time to developing a vaccine historically has been more than 10 years. I believe the quickest ever developed was within 4 years. And it's because it's a process of both the research, then the early animal studies, preclinical, then these phases where you give it to tiny numbers of people, 20, 30 sometimes, 40, 50. Phase 2, you give it to larger numbers, maybe 100 or 500 people to sort of see if you know the right dose, see if it looks promising, make sure there are no really severe side effects. Big phase 3 trials, often thousands, if not tens of thousands of people. to see if you significantly reduce the frequency of developing disease. And then finally, if it works, then you build factories and you start to produce hundreds of millions, if not billions, of doses. And then you get it approved, and then you try to figure out how to distribute it to 6 billion people on the planet or something like that. So you can see how this can take 10 to 14 years if everything goes right, right? Many of these start and they never even get to this point because they're either not effective or they're not safe. What the US government has proposed, and we're not alone, other developed countries and other countries are doing the same, is to try to figure out how to shorten the timeline because of the pandemic. So you can see everything is squeezed together. And I'll bring you down again, the academic research, preclinical, it all is still there. None of the steps that would be normally done are removed. The difference is they're done quicker. This project, so-called warp speed, and they're done almost simultaneously, meaning rather than wait and see if one thing works and then go to the next thing and see if that works and then go to the next thing and see if that works, go down, then if it works, start building factories and manufacturing. You can see here, this is no business model, but they're building factories and starting to manufacture before the phase 3 trials are done, meaning they're committing potentially hundreds of millions of dollars to prepare for manufacturing before you even know if the vaccine's going to work. So this is probably the most important part of the novel strategy for developing vaccines for the US and around the world, is to commit the resources to do all of that work in advance, recognizing that if the vaccine doesn't work, you've completely wasted your money. But if it does work, you can narrow the gap from the testing to the widespread distribution by many, many years. And that's the approach that's being used. So there are several vaccines, and the timing of this talk is great because many of you heard a lot of press in the last 2 weeks, and particularly yesterday, because yesterday was the first of the large so-called phase 3 efficacy trials to actually demonstrate in large numbers of people whether vaccines work. The first of the 2 US trials started yesterday, with a few sites in Los Angeles. The next of those trials, the third one that's funded through the US government, is going to be testing a vaccine that was developed at Oxford and is being developed with this company AstraZeneca. But it is all NIH funded, research funded through the US government, your tax dollars at work. And that study is targeted to open probably in the middle of August. So literally just weeks away. We'll see, but it's going to be around that time. And that's a vaccine study that we're going to be doing at Harbor UCLA and the Lundqvist Institute. It will also be done at USC and at UCLA. So we're all working together along with probably over 30 sites across the country. And let me just tell you, without going into a lot of the details about it, some real important pieces of information about these vaccines. All of the initial ones being tested, including this one, none of them are using live virus. So one of the reasons that I'm so pleased to have the opportunity to talk to all of you, and one of the efforts that my colleagues and I are attempting to do now before the studies even start, is to get out there and talk to people who we think are going to be important potential participants in the trial, or know people who might be potential participants, so that people have good information to make decisions. Ultimately, they're going to volunteer, and people need to feel comfortable doing that, but make sure they have good information. And while we don't know a lot about these vaccines often when we start with these phase 3 trials, there's a few things we do know, and one of them, which I know is a concern for people, is you cannot get this virus from the vaccine. So what it shows on the left is you start with a common cold virus from chimpanzees. Similar vaccines have been developed with human common cold viruses. And what you do is that you then alter it by inserting just the gene for a part of the virus that's important for developing antibodies that will protect infection to the virus. So you have the gene being edited on the right-hand top part of the slide and being inserted into the genes of this harmless chimpanzee adenovirus that has been created in such a way that it can't cause active infection. So while in chimpanzees it will cause a cold, in this, the way it's created in this setting, it will not replicate. It goes into the cell once and it dies. It doesn't do anything else except allowing that one gene from the coronavirus to actually be expressed on the surface of the cells on the bottom left. And then the body sees it. Again, there's no replicating virus. There's nothing even closely related to the coronavirus. There's just that expression of that one protein that we think is important to block infection, and the person develops an immune response to it, particularly antibodies. So that's the goal of this particular vaccine. The other vaccines that started yesterday, the other two trials also do not use the actual virus. They just have a tiny little piece of genetic material that expresses that one important protein. This is the vaccine that we're going to be looking at in the middle of next month. This is this Chadox, the thing created by the folks at Oxford University. There was early data published about a week ago from the so-called phase 1/2 study. This included giving about 500 people the actual vaccine. You can see the age was 18 to 55, so it was a relatively young, healthy group. They excluded people who had a history of infection. And then this is what they found from a safety perspective. Generally well tolerated. Local and systemic reactions were more common in those who actually received the vaccine versus the placebo. Giving acetaminophen or Tylenol helped. Mostly mild pain, feverish, chills, muscle aches. And I'll show you that data in a moment. This has been seen with other vaccines using this kind of strategy. They are giving a second dose at 28 days to increase the immune response. The reaction associated with the second dose was less than what was seen with the first dose. And there were no serious adverse events, no severe side effects, no hospitalizations in these 500 plus people who received it. So this just shows you, if I focus you a little bit on the top row of figures, you can see at the top of each of those figures, chills, fatigue, fever, feverish, headache, malaise, and so on. What is there in sort of the gold color are people who had mild symptoms. The orange represented those with moderate, and a little bit of the red with severe. And you can see that some of the side effects like fatigue, headache, malaise, muscle aches were not rare, 30, 40%, but almost all mild. And a little bit better if they got Tylenol first, which they'll be able to do in this study. So this was very helpful, at least in trying to provide information for anyone who participates in the study as to what they might expect. They will have some side effects, mostly mild. And you can see over time, that step-like pattern, that's days after the immunization. It goes out from day 0 to day 7. So you can see most of these side effects are gone in the first few days, and certainly almost all gone, even the mild ones, by day 7. And the important thing was, in addition to being reasonably well tolerated, it did what we wanted it to do. It induced these immune responses in virtually everybody that received the vaccine. So does this mean it will work? We have no idea. All I can say from this data is that it is as promising as you could hope for from a study of 500 people, in that it was generally well tolerated and it seemed to induce what we think are important immune responses. But none of that matters. The only thing that ultimately matters is that it reduces the risk of developing disease in people who are immunized. And importantly, developing disease in the people who are at the highest risk for developing bad disease. So one of our huge priorities here in this trial, and I won't go through the details of this, is to identify 30,000 people across the country. 20,000 will be randomly assigned to receive the vaccine. 10,000 will receive a placebo injection. And what we want to do then is follow them for up to 2 years. And what we're most importantly following for is safety, to make sure there are no unexpected safety concerns, and whether they become sick from COVID-19. So in order to answer this question and answer it quickly, we need to do this in areas in which there are a lot of infections. So Los Angeles is an ideal place to be having 3 sites opening to enroll the study, since, as you know, we're having a lot of infections in California and particularly Los Angeles. We also need to enroll people who are at high risk for developing symptomatic disease and bad disease. So one of our priorities in this study, especially working at a safety net hospital like mine, is to make sure we enroll minority populations that are at risk for bad disease, and we enroll people who are older with comorbid conditions. So people over 50, ideally even over 65, or with those underlying medical problems. One of our goals is to do this kind of outreach in advance. There's no study open yet, at least not at our site. Answer questions and to get feedback on the best way to get the word out so that people are aware of what the study is trying to do. We are indeed able to enroll people over 18 who have no history of infection, but we really want to enroll the higher risk over 50, comorbid conditions, people of color, to make sure that the enrolled population is highly representative of the US population and particularly the community that we serve. Because when it's all said and done, we need to know that this is safe and effective in the highest risk groups. And doing a study that only enrolls low risk people is not useful. We also need infections to occur. Now, obviously, we're going to encourage everybody to protect themselves as much as possible. We have no desire to send everybody out and hope they get infected. In fact, we will reinforce the importance of social distancing and mask wearing. But we know that even in those settings, sometimes people aren't able to protect themselves completely and they're at some risk. What we don't want to enroll, to be quite candid, are people that are completely locked in. People who are not going out, nor do they live with anybody who goes out on a daily basis. You know, my example is always my 88-year-old mother who lives in an independent living facility in the San Fernando Valley where they've been locked down for months. Basically, she doesn't get out and nobody gets in to see her. Fortunately, they've done a great job to try to maintain those people's morale during this ridiculous period of horrific isolation. But they're certainly doing all they can to try to protect her. She's not going to get infected. So what we're really looking for are people who do go out. Not necessarily don't need people who are going to bars and dance clubs, but people who are getting out or live with people who are getting out. Those are the people we're looking for. So with that, I think I will stop. Thank you all for your attention and your time. And I'd be delighted to try to answer any questions you have about vaccine research in general or anything else related to COVID.
Thank you so much. That is amazingly informative and very helpful. And I think especially the emphasis that this is not using the live vaccine, I think that's very reassuring to people. Maybe what we can do is encourage people to use their raise hand thing under participants. If you scroll all the way to the bottom, and you can raise hands, and then David, maybe you can identify people to speak.
Sure. Janet Turner's got a question.
So can you hear me?
Yes.
Oh, yeah. I left and came back.
Yeah, good deal.
So, Doctor, so many things you said were very, very promising. But I always like to look at both sides and the downside as well. So what came to my mind is if you're picking senior citizens who are vulnerable because of health conditions, aren't you picking people who are even more at risk of something bad happening in this study? And indeed, won't you have to put yourself out in the world and come up against COVID for you to really know if it works?
Yeah, those are really excellent questions. So let me address the first one. Absolutely. But in reality, if we're going to come up with a vaccine that's going to be useful, it needs to protect people who are at the highest risk. The only way we'll know it's safe and effective in that group is testing it in those people. And the advantage of doing it in a controlled setting like this, like a clinical research trial, is at least you're doing it carefully with lots of precautions in place. So what I mean by that is that when these studies are developed, and this is, you know, your question is so right on, there's a lot of oversight. So there are committees at the NIH who are reviewing all of the data and all of the potential risks for this and other vaccines before it's allowed to move forward. Then the FDA, as an independent group, has no interest in this particular vaccine or any other, that similarly reviews all of the data and the expectations. And they also review what is called the monitoring plan. And what that is an independent group, a large independent group, put together of experts by the NIH, who will then monitor the study on a regular basis. So we don't start the study and say, 2-year study, see you in 2 years and we'll see what happens. So what they do is they will then monitor at regular intervals. And they will be monitoring for both safety issues as well as events. And there's in place a system in which anyone who has what we refer to as a serious adverse event, so something above and beyond mild aches and pains or fever, that those are reviewed actually in real time. So if you just do this on your own outside of a study, you have no idea what's happening, and you could have a bunch of people have a really bad outcome before you even recognize a problem. The way these studies are designed, despite the fact that they're huge, is that these things are all going to be reviewed in real time along the way. Any serious adverse event will be reviewed at the time. If there's a signal or any concern that these are occurring more often than we would expect, this independent group can actually look and see who's getting what. No one else will know who's getting placebo or drug. This independent group, if they think there's a safety concern, is able to do that. So this is the safest way that you can test this, recognizing that you need to look at it in people who are at high risk, because they're the ones who are likely to benefit the most. So that's what people are getting themselves into, and everybody is made fully aware. For those of you who've ever been involved in a research project, there's another process. So I talked about what happens at the NIH, I talked about what happens at the FDA. There's also local institutional review boards. So every institution doing the study has their own independent review board that reviews everything to make sure that they feel that the measures are in place to make sure this is safe for the participants, or as safe as possible, right? If we knew for sure what was going to happen, we wouldn't need to do research. We don't. So there are all these systems in place to make sure we protect people. The second part of your question is, well, don't people have to be going out there and putting themselves at risk? Well, the reality is, unfortunately, people are putting themselves at risk, whether we encourage them to do so or not. We will encourage people to be as careful as possible to minimize the risk. So we're going to continue to do that. The number of infections that actually has to happen out of the 30,000 people for us to be able to show that there's at least a 50 to 60% reduction in risk is 150. So we don't need a lot of people to get infected to be able to show that there's a statistical improvement for those who got the vaccine versus those who didn't. And the whole reason that we need to enroll 30,000 is because we know the majority of those people are going to protect themselves and not get infected. So we need huge numbers to identify the relatively small number of infections that will ultimately allow us to answer the question as to whether we reduce the risk of developing disease in those who got the vaccine versus those who got the placebo. So I hope that answered those questions.
Thank you.
Thank you. Who's next, David?
Steve Jordan.
Are you on mute, Steve?
Yes, no, thank you. So my understanding is the end result we're looking for is fewer vaccinated people got sick. But since a large number of infected people are asymptomatic or minimally symptomatic, we're not really going to be determining if the vaccine prevented people becoming infected, but rather did it decrease the chances of them becoming infected and getting sick, if I understood correctly?
Yeah, this is an incredibly insightful question. Thank you for asking it. You're exactly right. You nailed it. The FDA decided the FDA decided, and I think it's a good decision, that the important endpoint from a study that would justify whatever risk and costs there are associated with the vaccine is to keep people from getting sick. Keeping people from getting infected and either being asymptomatic or having a cold is not justified for the cost and the risks associated with a massive vaccine effort that would include billions of people around the world. So the FDA decided that the endpoint for this study, the so-called primary endpoint, that the study needs to demonstrate to justify rolling out a vaccine is keeping people from getting actually sick. So that was the goal. Now, there are lots of so-called secondary endpoints. And one of those will definitely be what effect you have on people getting infected. So we'll be detecting blood along the way from people, and we'll be looking at the development of antibodies, both to natural infection as well as the vaccine. And you can tell them apart because the vaccine only has that one little virus, where natural infection you develop antibodies to lots of parts. So there will be secondary endpoints looking at it. But I think the FDA decided if you showed that alone and didn't show a benefit in preventing people from getting sick, it wouldn't justify the cost and risk associated with a giant vaccine effort. So all of the vaccines being developed are using a primary endpoint of symptomatic disease. But you're exactly right. That's what we're testing.
Thank you, Dr. Jordan. He's got an edge on us. He's an MD.
Yeah, that was the right question.
Who's next, David?
That was all the hands raised.
Okay, I guess my question is, for those people who participate in the trials who receive, those 10,000 people who receive the placebo, do they get any priority in receiving that the vaccine, when it's found to be effective?
Yeah, so another really great question. And this is something we've obviously been pushing really hard as the investigators. And the commitment that's made in the formally written into the protocol is the answer is yes. The devil is always in the details, in the specifics. And the way it's written in the protocol is that once something is shown to be effective and is reviewed and approved by the FDA, they would be a priority for allocation of vaccines. The timeline for that to happen is not always clear. So I'm always a little cautious in making those promises, but in spirit, that is clearly the commitment made by the NIH and the protocol team and us at the sites. Because the distribution of vaccines is going to be the next big step, even if we find something that works. Even though they're accelerating the whole manufacturing process and moving it up, you don't make, 300 million, and if it's 2 vaccines per person, 600 million vaccines overnight, even if you're prepared. So the rollout is going to be very deliberate. And I think the priority for the rollout will be the placebo recipients and that high-risk population, right? If we know it works and we know it's safe, we don't need to give it to 20-year-olds. Eventually, sure, because it'll protect their parents and their grandparents. But the highest priority is going to get it to the seniors, the people with comorbid conditions. And so it's going to be very deliberate as to how that's rolled out.
And as part of this study process, at what point would you be able to determine how long lasting is the immunity?
Yeah, boy, you're asking all the right questions. They're gonna, a big part of the reason it's 2 years is one, long-term safety, and also to try to get a hint of that. So for 2 years, we'll be looking at people having recurrence of infections or first infection. And that will give us a hint, potentially, across 30,000 people about the durability of immunity, at least for 2 years. We'll also be doing blood draws serially over the first year and at the end of the second year to look at those important antibodies to see if they persist, to try to give us an idea. Because that's always the next big question with vaccines is, how often do people need to be re-immunized?
Mm-hmm.
And right now we don't know that. And that we're hoping to learn that from this study as well.
Great, thanks. Now I know you have a website. Is that how people sign up for this process, or what?
Yeah.
You mentioned that you're starting maybe mid-August. How does that work?
Yeah, so the group that's sponsoring all of this, that's part of this Operation Warp Speed from the federal government, as this Coronavirus Prevention Network group. And their website is coronaviruspreventionnetwork.org. It went live a couple weeks ago. This is all happening incredibly fast. So if it feels like, gee, why is this guy talking to us now when one study opened yesterday and the other one's going to open in 2-3 weeks? It's because we literally just saw the protocol, how the study is going to be conducted in the last 2 weeks. Everything is moving at warp speed, as they say. So that has a volunteer site. In addition, it's a great resource because it has a lot of information about vaccines and a lot of information about prevention and COVID-19, but it also has a volunteer site. We are also working locally on our own outreach, where, again, at some point when the study is ready to go in the next 2 or 3 weeks, what we're going to try to do is get the word out from various different mechanisms, including usual things like flyers. Hopefully maybe I can get information out to all of you, and it's something if you feel comfortable sharing with others or other groups you work with, and that would be fantastic. And that would have what I hope will be a separate website for us locally. So that people want to come on, they can see if they're eligible and schedule an appointment. And those are all things that we're actively working on right now. So for now, anybody who wants information about the general process, coronaviruspreventionnetwork.org. And then hopefully sometime in the next couple of weeks, we'll be able to get more specific information about the local effort out to you. We actually can't distribute any of that until it gets approval from our local institutional review board, that group that's responsible for making sure that we maximize the safety of the study and that any information that we're putting out there is completely appropriate and vetted and non-biased, so that people are truly aware of the information, not just somebody who has a vested interest in this, myself as an investigator that's funded by the NIH to do this work, but it's an independent group to make sure that anything we distribute is appropriate. We'll emphasize things like volunteer, and we'll emphasize that they'll be provided all information about the study, including the risks.
Mm-hmm. Now that 30,000, is that a national number, or how is that distributed among the different, like how many would you be registering?
Yeah, so it's going to be first come, first serve. Nobody wants to hold up anything for enrollment. Our target locally at our particular site is 500. None of us have ever done anything like this before. We have no idea if that's going to work. We know there are lots of obstacles to getting, one, the word out, two, overcoming people's concerns, which is why we're trying to be proactive in sharing information and answering questions. And we know there's a lot of distrust out there, especially about vaccines, which again is why we want the information so people can make an informed decision. But that's our goal of 500. The study will enroll with or without us meeting that target. It's just a matter of time. The hope is that it will enroll over 2 months. That's the target. We'll see. We're also, there's going to be a huge national campaign, advertising campaign that we're told is in the works, and that hopefully we'll all start to see it, and it'll reinforce that this is all going on at our local sites.
Great. That's very helpful. Any other questions, David?
Yeah, we have one more from Janet Turner.
And actually, before Janet speaks, I just wanted to let everyone know I put the website that Dr. Darr referenced, the coronaviruspreventionnetwork.org. It's in the chat box.
And I wanted to recognize we've been joined by Gardena Councilwoman Francis.
Oh, welcome. And Janet, you had another question? Janet is with Congressman Ted Lieu's office.
Thank you.
So is it Darr, Dr. Darr?
Yeah, Eric Darr.
D-A-A-R.
I just wanted to make sure I was pronouncing it correctly. So let me, before I ask my question, let you know that I am a huge fan of CAR T cells therapy.
Oh, wow.
And I have heard about Dr. Sun Xian's
Yes.
vaccine, which, as you know, the CAR T cell would help keep that immunity in the body for a much, much longer time. Have you looked into that at all?
So I showed you little pieces of that phase 1 paper, phase 2 paper. What I didn't show you was the specifics about the immune response, but they did look at some of those cellular immune responses. Again, it's not long-term, which I know is one of the things that, one of the potential advantages of cellular immunity is that memory that will come back when somebody's exposed a year or 2 or 3 years, long after your neutralizing antibodies have gone away. They obviously didn't have that kind of follow-up, but that will be done as part of this study out to at least 2 years, where they'll be looking at not just the antibodies, which we think are important, but also these T cells responses.
Thank you.
Great question.
Well,
We have
thank you so much.
one more question from Melissa.
Thank
Okay.
you, David. This is Melissa from Beach Cities Health District. Thank you for all the helpful information and your support. If you would be able to send that over to Grace so she can disseminate in terms of just the outreach and the education piece when you have that in regards to enrollment interest, that would be wonderful, please.
Of course, I would be delighted. That would be terrific. I appreciate the opportunity.
Thank you so much.
Okay, any last questions? Hearing none. Thank you so much, Dr. Darr. This has been very helpful, just a wealth of information that I know many of us who work with senior groups and other low-income groups, and that, you know, we will be very interested in trying to disseminate this and to help you in whatever way we can.
I appreciate it. And Britt has my contact information, so feel free. I think she has my cell phone number. I know she has my email. Please feel free to share those with anyone on the call that wants to get additional information.
Wonderful. Well, thank you for joining us. We're going to go on with the rest of our meeting. I know you've got a busy day, so we'll let you go, but thanks again. We appreciate it.
Thank you. Bye.